Most AI projects follow the same pattern. A team identifies a use case, they build a prototype, leadership gets excited, and then 6 months later, the project stalls in pilot. Or worse, it launches and creates problems nobody expected. Usually, the issue isn't the model, it's the implementation. What's interesting is that the same mistakes show up repeatedly across industry, across company sizes, across completely different tech stacks. And they usually happen at the same three stages: before the build, during the build, and after launch. In this video, I'll walk you through the most common pitfalls at each stage and what teams can do to avoid them. Let's start with the earliest phase, before the build. Two patterns show up constantly before any code is written. The first mistake is forcing AI onto problems that don't actually need it. Right now, AI is becoming a priority in almost every organization. So suddenly, every workflow starts looking like an AI use case: scheduling, routing, pricing, searching, or reporting. But many of these problems are still solved more effectively with traditional systems like rules, automation, and optimization logic. Sometimes the best solution is still the simplest one. The question always worth asking is, what's the best tool for this problem? A good implementation partner should be willing to tell you when AI is the wrong choice. That usually saves far more time and money than forcing AI into a workflow where it doesn't belong. The second mistake is building on systems that aren't ready. And this catches a lot of teams by surprise. The information itself may be accurate, but accuracy alone isn't enough for AI systems. The information also needs to be organized in a way the system can reliably retrieve and understand. Because in many companies, important context is scattered across PDFs, slide decks, internal tools, and disconnected documentation. Humans can usually navigate that mess. AI systems struggle with it. AI extracts based on how information is structured, labeled, and connected. It relies on explicit organization. When critical context sits in slide 47 of a deck from last quarter, the AI misses it. That's why AI systems depend heavily on information architecture. The system needs information that is accurate, structured, current, and explicitly connected. Otherwise, you end up with a dangerous outcome. The AI sounds confident while still missing critical context, and that's often much harder to detect. Fixing the information architecture helps avoid this mistake early on. Now let's move into the build phase. This is where teams often confuse something impressive with something deployable, and those are very different things. A prototype can often be built very quickly. It answers questions, summarizes documents, automates part of a workflow. Leadership sees it working and assumes the project is almost finished. In reality, the hard part usually hasn't started yet because demos operate under ideal conditions, while live products must survive real-life chaotic conditions. The gap between "wow, it works" and "we can trust this in production" kills more AI projects than bad models ever will. Getting to impressive is the easy part. Getting to reliable is the actual job, and it's what takes time and expertise. Another common mistake is overbuilding too early. Teams often jump straight into multi-agent systems, orchestration layers, vector databases, fine-tuning pipelines, and elaborate toolchains. Sometimes that complexity becomes necessary later, but very often it's premature. A simple model call with clear prompting often works best. Retrieval plus good workflow design. With this, you can prove value without maximum architectural sophistication. Early complexity creates a worse problem. It hides failure. Simple systems break visibly, allowing you to find and fix the issue. Complex systems break mysteriously, and when everything is abstracted behind layers of tooling, debugging becomes dramatically harder. So, I recommend starting with the simplest version that proves value and seek out complexity only when it's absolutely needed. Another trap is blaming the model when the real issue is product design. A team launches an AI tool, users try it once and never come back. So the team assumes the model needs improvement. They tweak prompts, swap models, add context, maybe even fine tune it. But the actual issue lies in user experience. Users simply weren't guided properly. They opened a blank interface with no examples, no structure, and no indication of what the system actually does well. That's a product problem, and better models won't fix it. Good AI products guide users toward useful outcomes. They show what's possible, structure the interaction, and fit into real workflows. When adoption is low, the product questions come before the model questions. A related issue is treating human in the loop as a safety strategy without designing the actual workflow around it, because eventually someone has to answer very practical questions. Who reviews outputs? When do they step in? What are they checking for? How much time do they realistically have? And what happens when volume increases? Without clear answers, human review becomes a slide in a presentation, not an operational safeguard. Product thinking applies to both the user facing experience and the review workflow behind it. And then we get to the final phase, after launch. This is where teams often make another mistake. They treat AI systems like traditional software, but production AI behaves differently. These systems drift, they decay, and they change over time. One major issue is weak evaluation. Some teams test a few prompts, get reasonably good answers, and assume the system is ready. But that isn't real evaluation. Reliable AI systems need representative test cases, edge cases, adversarial testing, and ongoing review after launch. Automated evals help. LLM as a judge helps, yet neither replaces human judgment for the things that matter most: usefulness, tone, business context, and appropriateness. Weak evaluation will show up later on. The system may look fine until a user hits an edge case that reveals a huge fundamental flaw. That's why evaluation should be an operating discipline, continuing as long as the system runs. Another challenge is operational fragility. AI systems become more brittle as they become more connected. Every additional layer creates another potential failure point. The system retrieves the wrong document, selects the wrong tool, passes incomplete context forward, or behaves differently after a vendor or model update. And sometimes nothing breaks dramatically. The system simply becomes less reliable over time, quietly. Knowledge bases get stale, documentation falls behind. The context the model depends on becomes less reliable over time, and a system that worked well on day one slowly gets worse. That's why production AI requires ongoing operational ownership. Prompt maintenance, retrieval tuning, monitoring, cost tracking, security review, model testing, business alignment. Higher risk workflows require human involvement at decision points. Production AI is operationally alive. It needs ongoing care. The pattern is actually very consistent. AI projects fail before the build when teams choose the wrong problem or build on weak foundations. They fail during implementation when teams confuse demos with production systems, and they fail after launch when evaluation and operational ownership are missing. The companies shipping useful AI usually do the unglamorous work well. Clear scope, strong foundations, simple architecture, careful rollout, disciplined evaluation. Behind all the hype, that's still the real work. We're putting together more resources around AI implementation, operational readiness, and red flags to watch for early. If you're working through challenges in this space, my team at Fram helps companies navigate exactly this kind of work. And if useful, check out the checklist link below for a quick framework to help avoid some of these common mistakes. Thanks for watching.